If you step off a ledge, you accelerate noticeably towards the Earth because of the gravitational interaction between you and the Earth. Does the Earth accelerate towards you as well? Explain. Yes, it does, because when the Earth pulls you down, you pull the Earth up, although the Earth has so much more mass that it barely moves at all. Number 2, suppose you're weighing yourself while standing next to the bathroom sink. You're using the idea of action-reaction. Why does the scale read less when you push down on the sink, and why will it read more if you push up on the sink? So, if you're this guy here, and you push the sink down, if you push the sink down, the sink is going to push you up, so there's less weight on the acting on the scale. Whereas this person, when they push the sink up, the sink pushes them down, action-reaction, and the scale reads more. Number 3, what is the reaction force to the action of 1,000 newtons exerted by the Earth on an orbiting communication satellite? Well, if the Earth pulls the satellite with 1,000 newtons of force, that means that the satellite pulls the Earth with 1,000 newtons of force. Number 4, if action equals reaction, why isn't the Earth pulled into orbit around the communication satellite? Even though there's the same force acting on the Earth has so much more mass that it barely moves compared to the satellite, which moves around the Earth quite a bit. Number 5, if a bicycle and a massive truck have a head-on collision, upon which vehicle is the impact force greater? It is the same on both. Which vehicle undergoes a greater change in motion? That is the bicycle, because it has less inertia, so therefore it's easier to change its motion. Number 6, some people used to think that a rocket could not travel to the moon because it would have no air to push against once it left the Earth's atmosphere. We now know that that idea was mistaken. What force propels the rocket when it's in a vacuum? When the rocket pushes the exhaust gas backwards, the exhaust gas pushes the rocket forward is the answer to that. Number 7, since the force that acts on a cannonball when a cannon is fired is equal and opposite to the force that acts on the cannon, does this imply zero net force and therefore the impossibility of accelerating a cannonball? Well, of course we know cannons work, so they don't cancel out. And the reason they don't cancel out is one force is acting on the cannon and the other force is acting on the cannonball. So they don't cancel out because they're on different objects. Number 8, suppose you exert 200 newtons of force on your refrigerator and push it across the kitchen floor at a constant velocity. What force of friction does friction act on the refrigerator and the floor? Well, since it's moving at a constant velocity, we know that there's got to be something with 200 newtons that's canceling out your force, so that would be the force of friction. Is the force of friction equal and opposite to your 200 newtons push? Yes, it is. Okay. Does the friction force make up the reaction to your push? Okay. No, it does not. Okay. The action-reaction forces when you push on the fridge is when you push the fridge forward, the fridge pushes you backwards. That's the action-reaction force. Number 9, what will the spring scale read? The spring scale will read 50 newtons. I don't know if I tricked you on that one, but that will read 50 newtons, just as if it was hanging vertically with 50 newton mass hanging from it, and you were holding the top of it, like reading it, because you would still have to exert 50 newtons to keep it from falling to the floor. Number 10, the strong man can only withstand the tension force exerted by the two horses pulling in opposite directions. How will the tension change if he's tied to a tree on one side? Well, these two are identical. So the two horses pulling and the one horse pulling and a tree pulling. How would the tension compare if two horses were pulling in the same direction and the left rope was tied to the tree? Now this one, in this case, now he's got double the tension because he's got two horses pulling him to the right, and he's also got the equivalent force of two horses pulling him to the left if he's not moving. Number 11, a hot air balloon floats motionless in the air. A balloonist begins climbing up a ladder or climbing up the supporting cable. In which direction does the balloonist climb? Which direction does the balloon move? Well, when the balloonist goes up, the balloon goes down. Okay, so and would be the answers to those questions. So hopefully you did well on that, and we will see you soon.